Good evening, everybody. Our next speaker is known. Our next speaker is known to cause a little bit of fear in recent years with the guys from Cisco. He's also had his focus on core infrastructure of the internet. And in this talk, as you all know, we do have lawful interception interfaces in all the core infrastructure running our internet. But there's a big question. Could this lawful interception interface pose an additional risk to attack? Please give a warm round of applause to FX.
Oh well, Snowden. So basically, this is the technical side of the lawful interception point. Unfortunately, we can't really. We submitted another talk on the political side together with the gentleman over there, Mr. Robert Lee. Unfortunately, it was turned down because he's with the United States Air Force. So you know, this is not censorship. But yeah, if you want to be a censor, then your intelligence should be good, and you shouldn't miss that the guy who's allowed to talk is with the NATO as a co-director. Anyway, so what are we talking about? What we're talking about is like the game of lawful interception, what actually turns out to be pretty much a game. So what's the justification? Who are they looking for? Why are they watching you watching porn? The inherent problems with lawful interception in the game map, then we play one side, we play the other side, and we have conclusions, and then we get drunk. So, awful. This talk is IP-centric. Keep in mind that every communication you do since a couple of 100 years can be lawfully intercepted, right? So this one is IP-centric, but there's other things, email, snail mail, wired phone lines, which we actually don't have anymore, mobile phone networks, and stuff like that. Also keep in mind that I don't know shit about this except for I look at it, right? So this is about reading standards, reading code, reading books, making fun of people. Hey, Torolf, we have an empty seat on the stage. Come on. So what's the justification? So basically, lawful interception means there's a law enforcement agency, LEA, which, in contrast to Star Wars, is on the bad side. And the idea is that they need to listen into communication from bad people. It's legally, and that's really interesting, legally rooted into the idea of looking at snail mail. So it's a different thing if the police looks at the envelope of your letter, which the NSA calls metadata, or they open the letter and look at the letter. So that's where the legislation comes from. And actually, lawful interception is not, in principle, a bad thing, because basically, if your child is kidnapped and then the ransom note comes by email, you're going to ask for it. You're going to ask the police, can't you tell me where this fucking email came from? In Europe, the whose deck phone is that? Because it's ringing. Now, I did that a couple of congresses ago. Anyway, so in the European Union, the legal basis of that is the Council resolution from the 17th January of 1995, so it's quite some time ago, which again is legally rooted into the Maastricht Treaty. And basically the Maastricht Treaty says that we have police cooperation for the purpose of preventing committing terrorism, that's all of you, unlawful drug trafficking, which immediately caused me to ask, like, okay, who's lawfully drug trafficking? I mean, you know, you need to know supply chains. And other serious forms of international crime. The national legislation that then implements that differs slightly between different European countries. One of the primary things is how much the network operator is allowed to say. So, let's look at the game map. You know, before you play a first-person shooter, you better learn the map, right? Basically, there's two sides. There's the people that built the internet, not the ones that asked for it and had it built and pay for it, because that's the US military, and well, if you're surprised that they want it back, that's your fault. The IETF, funnily enough, has an RFC that is aptly numbered 1984. And that RFC basically says, you know, everyone should encrypt everything from point to point. And, you know, circumventing this encryption has no proven benefit. The NSA might beg to differ. Years later, the IETF came on with the policy on wiretapping, where they had a couple of interesting points. One series is that tools which are effective for a purpose tend to be used for that purpose. Oh, surprise. However, what they're not saying is everyone can do that. That doesn't mean it's the people that you build it for. The second point being tools designed for one purpose that are effective for another purpose tend to be used for the other purpose as well. This is commonly known as HTTP. And then if a vulnerability exists in a security system, it's likely that someone will take advantage of it sooner or later, and that's what this talk is about. So in the same RFC, they basically sum up the security considerations with 3 points, and this is really important for this discussion. The system is less secure than it could be had this function not been present, because you're extending the attack surface, right? The system is more complex, and it could be had this function not be present. Same argument. Being more complex, the risk of unintended security flaws in a system is larger, known as PRISM. So basically, wiretapping, even if it's not used, therefore lowers the security of the system. In today's world, you would say wiretapping, if it hadn't been implemented, wouldn't allow PRISM to exist. Why is wiretapping so difficult? So, first of all, Lawful Intercept, as many government-regulated functions in an ISP, is a cost center. So Google doesn't make any money with watching you. Well, scratch that. They make all the money with watching you. Your ISP, at least in Europe, wouldn't make any money with watching you. However, here's a basic calculation from one of the books on the subject. So the one-time cost is 7 or almost 8 million. The annual cost is like 38 million. And then if you're lucky, you get 25 million back from the government, which by itself is questionable. But like, if you're not less bad in math than I am, you will notice this is not a positive sum game. The next thing is performance and operations. So the operation of the target, like the service must appear to be unchanged. Do you know any gamers in here? What do you think you will do when your ping times go down like 200 milliseconds? which was actually triggering the naming of the talk. So that is one part. The next one is during interception, lawful intercept agencies may require information and assistance, blah, 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 AKA they have no fucking clue and they call your network administrators. The third part being like the telecommunication to and from the target service be provided to the exclusion of any telecommunications that do not fall within the scope, which means they tell you who you're supposed to monitor, and you're fucking responsible to make sure that you're not monitoring the wrong people. Wait a minute. But then there's like the basic IT, and I'm a networking guy, there's basic bandwidth issues. Transmissions forwarded to the monitoring facility to comply with the performance standards of the network operators. A bullshit statement to begin with, but let me explain why this is really interesting. So this is how we actually envision the internet to be, right? So, you know, you have an access point. What the hell? Let's drink Jägermeister. So that one is already open. I've never been applauded to getting drunk. That's awesome. Basically, this is how we envision the internet. Where basically this is what DARPA asked for. So if you bomb one side with a nuke, things still work. So on the right side, you have the webcam that you pay for to use. And on the left side, you have the average nerd, me included, certainly, that has an ADSL line. This is what the two arrows mean, right? So this tries to sum up that, you know, the military built the internet, the poor made it big. Basically, this is what the military and famous universities worked on. Now, a couple of years ago, I was on a conference in China. And after 2 hours of the introduction speeches from professors, I thought I'm on a wrong conference, but all the other speakers that I knew were still there. And I thought I'm on the wrong conference because they kept talking about the sensor network, as in sensoring. Because the network topology changes drastically if you're monitoring everyone. And this is what the Chinese network looks like. Basically, on every single point, you need the sum of all bandwidth that goes into the point and out of the point to be collected into your monitoring station. And this is why the Chinese actually call their local network their sensoring network, because it basically is not sensoring not with a C, but with a sensor, like it says on the slides, because that's the topology, and that means completely different routing patterns and all that things. Good. Okay, we understood the basic problems. Now, what's the gameplay? So, this is a slightly adapted explanation from Wikipedia about CounterStrike. We're talking about a first-person game in which the players join either a terrorist team or the counter-terrorist team. In contrast to CounterStrike, not all become spectators. They do it to become spectators. What points do we actually have? Like, where could you take the data of the network and, you know, watch me watching porn? There's the acquisition at the source. In Germany, we call that Quellen TKÜ. There's the next hop, which is the like plastic router that you get from your ISP or Media Market or whatever. There's the most common way of doing it in the network access layer, which we're going to cover in more details. There's SS7 probes, which is really interesting because it allows you to monitor phone calls, SMS, and stuff like that from across the planet. You don't have to be in the network stream. You can actually, like, you know, tell the SS7 network, give me that SMS. There's data retention, which basically means someone else is monitoring the stuff for you and runs an Oracle database that nobody cares to shit about because it's a cost center. And, well, there's all your communications for the last half year in there, which I'm sure no foreign secret service will find interesting. There's DNS triggered interception. This is what I would like to say less free countries, but by now I'm not really sure about that. Use. And then there's the threat actor of the type global observer, which, as far as I know, is a term that the NSA actually coined for designing crypto algorithms. So we're playing on a good side now. We're the counter-terrorists, which means let's arm up and get them. So, of course, we play the counter-terrorists because we're all the good girls, guys, whatever in between, and an android. This is how it looks like. So the US has a slightly different model called CALIA. In Europe, we use the ETSI model, ETSI. So basically, that has three interfaces. The first interface, it looks like the computer interface, but it's actually an interface between people. So yes, there is people involved. So the he one will talk to the network operators, legal people, and say, we have this warrant or whatever, we're the French Secret Service or blah, blah, blah. Can we please have that interception? The second interface, IRI, is what we all know as metadata. So if you have an IRI feed, that is in an email to, from, subject, basically the entire header. On IP communication, it will be the IP header plus TCP or UDP if they can recognize it. The content of communication means TCP dump, save everything, right? So this is three different ways of dealing with that. And as you see with the big bubble, it's all the fucking ISP's fault. Yeah, the police just won it. And this is far from complete, but I liked it because there's a couple of vendors. SS8 is, as far as I know, from Israel. They're interesting because most of the configuration templates that you find on the net, like, okay, I'm running an ISP, I'm new in my job, how do I configure LI for blah, blah? This is what they get sent. Now, imagine you have absolutely no clue on what you're doing, and someone sends you a line of configuration for your Cisco. What do you think happens? Control-C, Control-V, send. So not surprisingly, SS8 passwd is a very common password. There's other vendors. Interestingly enough, because like I pointed out that Lawful Interception is a cost center, most of the LI vendors actually market their stuff with billing systems. There's books on return of investment on Lawful Interception. And this is like the second case. I would like to point out that the number 3 to 5 are followed by AG, as in German company. Guess who's the biggest vendor in the world? There's interesting features. Like some companies have that feature of IRI information is sent to you by fax. Excuse me? Like the next one, they have an add-on that converts voice-over IP calls into ISDN calls. Now, let me think. I can produce about 200,000 voice over IP calls per minute at home. How many ISDN lines do you have? And there's all kinds of interesting stuff. So here's just a takeout from one of the vendors, and not necessarily one of the mentioned, that says things like it includes optimal granularity to preserve privacy. Okay, so you rebuild myself out of Legos. That's fine. So it captures only the traffic to and from the entity listened on the warrant. Yes, because that's the only traffic you should fucking get by legislation. Poser. It operates at high speeds. To be precise, the high operation speed is measured in GPS. Yes, it ensures the blah, blah, blah. And the traffic interception happens in the core network, minimizing the number of devices that need to be, let me replace that, owned. So this is what we're looking at, right? Now, what blew me away, if you know me for a while, Cisco actually published their Lawful Intercept interface with the IETF. They made an RFC out of that. The IETF went full FIFA mode, like, I'm not talking to you. This is all your problem. For good reason. But what the fuck? I mean, Cisco is the only fucking vendor that does the right thing and has the LI interface peer-reviewed. You know, parts of my worldview started to crumble on the left side. But then, you know, I looked at it and I'm like happy because, okay, cool, it's still Cisco. The authentication design is a complete failure, simply because the law enforcement authentication and authorization tabs happen at the mediation device. Now the interception and the question, where do you send the traffic that you intercept, that happens on a router. Let's see. So this is from the RFC. And so basically, he1 is the non-technical interface. I assume that by now the LI administration function is a web interface that both company lawyers and police access. I wonder how. And this configures, in the center, there's the mediation device. So the mediation device talks to IRI, metadata collection. As far as I know, Cisco doesn't have any. You're gonna fucking kidding me. Okay, I apparently need to hurry up. And so the rest happens there. So to let pictures speak faster than I do, this is basically how it looks like. And, oh my God. I'm at slide 20 or 44 and 15 minutes left. Good. So this reference model basically says here's SNMP v3. That's common, well-controlled. Everyone knows exactly what they do. You need authentication. But the thing is, everything you do is a single UDP packet. The mediation device does all the bullshit. It manages whatever, and the router only does what it's supposed to do. Well, LI basically violates the basic, absolutely pure basic design principle of a router. Because LI matching happens in what's called the critical path. Why do you buy a router? Take packet from here, move it here as fast as you fucking can. Alternatively, look at it. That means your porn feels like in the 80s. So, and that's illegal, as I told you. So routers are not meant to do that. So the way Cisco implemented that, and that's actually not stupid, is the closest they found was access control list. The problem is every time they invent a new forwarding technique, a year later, there's a Cisco advisory saying, oops, access control lists are not matched on this. Yes, so for interception purposes, they actually built them on the fly. Let's see. So this is how a mediation device looks like. This is a checked version. So you basically say who, what, when, porn. How do you protect that interface? Authentication is actually required. So you can't, no matter how stupid you are, you can't configure SNMP v3 for LI without authentication. And there's a couple of other values that you need, but basically there's also access control lists for so-called infrastructure ACLs in place, so not everyone in the world can talk to you SNMP, hopefully. You can bind this to user groups, nobody cares. You can encrypt this, nobody cares, because it's LI, nobody fucking cares. We want to run a network. Then came IPv6, different story. And there's notifications, so it tells you when there's lawful interception going on, but this is not meant for network operators. This is meant to be sent to the mediation device. So, you know, it pulls its head out of its ass. So, counter-terrorists win, right? That was the point. This is why we put this all in place. Now, just for educational purposes as a thought experiment, we're going to play the other side. The options that we have is, point one, do whatever terrorist known on the world does, not using the internet. For Yep. It took me a couple of years to realize that those mules are not actually transporting IP traffic. So, alternatively, what we can do is use traffic that is not intercepted, detect interception, or take over things. Traffic not intercepted is not something we really have to do much for, because so here's a couple of bugs that showed up. So in iOS XE, the lawful intercept feature needs a license. They turn to expire. And keep in mind, this is something nobody fucking cares about it. The VRF-based interception, VRF as a virtual routing frameworks, basically, if your company is like, we don't need encryption because we have an MPLS or a service provider, virtual private network over the internet, those are not encrypted. And even if they are, they're encrypted between point and point. So if Lawful Interception Agency wants to listen to your traffic, here they go, right? The thing is, keep in mind, you should notice that this happens. Things break, like minor things, like policy-based routing. Nobody uses that. Server load balancing. Whoever has a web farm has never heard of it. You know, basic things. Then LI in general is prioritized over other features. So other features that break, optimized ACL logging. I imagine this guy at Cisco going like, we have the optimized ACL logging, and they see the interceptions going on because we build ACLs. Duh. There's other ACL matching. What I really like is the bug report makes a very honest statement. Intrusion detection systems, IDS, not functioning properly. which is a general statement, I'm fine with it. But the funny thing is, you're running a provider network, someone gets monitored, your IDS only sees the monitored guy anymore. That's the only guy they see. So basically, all you need to do is troll someone else far enough so they get intercepted, and then you can do whatever you want. What the fuck? Now, there's other things, right? So here's the Cisco bug. If you actually buy additional hardware and put it, you look so cute with that. You put an additional line card in your access router just for zips, so the police can listen better to VoIP calls. And the result is, it doesn't work anymore. There's also, this other bug that I really like. So basically, the SNMP communication doesn't work anymore. And the workaround, I love. You may be able to restart the SNMP manager to force the timer for SNMP engine to resynchronize. Note, however, that doing so causes a 100% outage for all wiretaps that are served to the SNMP manager. If you cannot restart the SNMP manager, there's no workaround. This is verbatim quoted. Now, if you have so much fail, then there's a tendency to look for, can I make more fail? So stateful switchover and nonstop forwarding are major selling points for routers, in this case, the naming is Cisco, but for router vendors in general. If you have a site that is somewhat interesting, you actually have more than one router, and you have, hot standby. The thing is, this doesn't support LI. So if you have a switchover, all the taps are lost. Interestingly enough, if you cause a switchover, every router vendor in the world will tell you it's not a security issue as long as the other side took over. Yep, it's not a security issue, it's an LI issue, but that's not your problem. And the other thing that I found is that the domain name for both the router and the mediation device, I hope nobody gets zone transfers from ISPs, are actually registered with the DNS. And I defer to Dan Kaminsky to tell you what's wrong with that. Now, size does matter. If she told you otherwise, she lied. So Leah has the problem of, by requirement, they want to have the same bandwidth as you have. And not everyone does interesting things from home. There's people that have big pipes at work, right? And there's interesting stories about, especially the German police intercepting, where they're not saying, give me this HTTP traffic, but they say, we don't know what this guy does, give me everything. And then they call 10 minutes later and say, what the fuck, we only have a Pentium 1, turn the shit off. That's what I was trying to point out with a sensor network. So, also, somehow the vendors managed to negotiate, that's what you have lobbyists for, top-level load on the routers, because nobody wants to pay for the police watching you watching porn, right? So basically, here's some examples. You can only intercept 2% of the calls. Given the fact that running a VoIP gateway is a relatively cheap thing, find some other 8 people that generate interesting stuff. And there's also bandwidth problems. They really fucking hate you to mirror the world and then, go partying. And numbers do matter. So there's other interception mechanisms that are not Cisco that use flow tracking. Now, flow tracking is random sampling. if you download enough documentation, records of the talks here, this one little email is very unlikely to be caught. And then there's the compromised observer problem, because basically now you have two IP stacks that need to understand what you're talking. And that's why IDS doesn't work, this is why IPS doesn't work, period. Because now you have a combination of two recipients, so there's many different ways to fuck this up. Basically, it's like with an antivirus solution. The antivirus solution can't unpack the zip file. Your Windows zip tool can, or unzip on Linux can. So the antivirus solution has no fucking idea what you're looking at, and you get infected. This is all LangSec. If you haven't understood that, keep getting out. Whoops, wrong direction. Fat fingers. So what I said about the code in the critical path, basically what it means is the people at the router vendors try to get out of the code for LI as fast as possible, because they're not liable. Neither the ISP nor the router vendor is liable for not intercepted packets when they're not well defined. So this, for example, looks for, oh, IPv4, cool. IPv6, cool. Let's go. Now, IPv5 is what I call a laser packet. Because lasers don't pass through prisms. Take a prism, take a laser, try it. I'm boring Fukami, I'm sorry. So basically, what I tried was take a regular IPv4 packet or packet stream and just like replace the version to number 5. What's funny is there's a number of routers that actually forward that, and there is a number of recipients that actually answer. That doesn't make sense unless you look at the entire OC layer stack. Because on the data link layer on layer 2, there's a number of protocols that hint on what is the transported protocol, right? So, example for Ethernet, IPv4, we all know. IPv6, I actually learned from a professor that why is IPv6 better at transporting porn? Because it's 86 double D. That's not my thing. His response was, how else do you make the students remember? So basically, they take the hint from the layer 2 protocol and ignore half of the IP header just to get rid of the packet faster, because they're built to, get rid of the packet. How do you get around interception? Now, one of the things is what you just saw here, but I'm skipping this for time reasons before Hades kills me. To punt a packet, this is what this thing here shows. Like, we can't figure out shit and we punt a packet. To punt a packet means you're handing, like we're talking about a router this size, and you're handing the packet all the way up to the main CPU. Now, the main CPU is actually not there to forward packets. It's basically like when you have a company with a couple of hundred employees and everyone escalates every problem to the CEO. At some point, the CEO reboots, or gets handed off to medical people. This happens with Cisco's as well. So the interception target can basically just produce perfectly legal packets and send to whoever it wants. I'm not a lawyer, but this should actually even be legal in Germany. This pushes the CPU to 100% load, like Java. And there's, in contrast to your PC or Mac, there's a watchdog process on Cisco that kills the machine and reboots it when the CPU is hanging on 100% too long. Now, consider the following. you have a communication partner. Let's say he's in an embassy in London. And you want to have a secure communication with him, so you trace route to his IP address. Then you send like 10,000 packets, which is not a lot, and then you trace route again. If the trace route changes, usually like the third or fourth hop, there's an access router on ISP just rebooting. The thing is, you don't have to be fast because they actually take about 20 minutes to reboot. Now, if you come up with the idea, well, let's take over the Lawful Intercept device, that's a really bad idea. Although, like Windows 2000 or Sun Solaris is like probably years old older and still have for that, that not a good idea. No, because there's people that are called compliance people, and almost. And you know, they hate you because their job is to watch the compliance of this device, and root shells on that device are not good. If you plan to attack the basically police, like forget it. Taking over the interception point, being the router. Well, there's this bug from 2008, and routers are not commonly updated. Which, you know, takes SNMP v3. Here's the MAC coming in. I love you, thank you. Here's the MAC coming in. Here's the MAC that we have stored. We're allowed by RFC to compare a subset. Nice. If the packet says the MAC length is 1, then the attacker only sends 256 packets and is certainly authenticated. Interestingly enough, Tom Cross found out that of all Cisco images, everything was vulnerable except for most of the ones that had LI functionality, which is interesting by itself. But also SNMP v3 gives very detailed feedback on the authentication failure. So it tells you username not known, password not known, you're coming from the wrong address, blah, blah, blah. When we talk about the ACLs, remember that we're talking about UDP. So the best practice, best common practice documents for providers say prevent spoofing from everywhere outside your network. You're in their network, you're their customer. And apparently people have covered attacking Cisco IS before, I don't know. Anyway, so what does that mean? Terrorists win. So the German term is Erledigung durch Zeitablauf. So you're basically just waiting for everyone else to put more interception code in. But in fact, like, I don't think anyone in this room is a terrorist unless they're paid for it. So this is what we're actually looking at. Nobody would, like, no terrorist organization would hire a hacker. First of all, you know, they smell funny, and second of all, they actually think about the mission they're sent on. But you can make them do things, and that's the big risk in this. So, conclusions. First of all, routers shall not parse packet payloads. Please do me a favor. Like, anyone, read the fucking manual. This time start with the OSI model. You're not allowed to parse anything except for the IPv4 destination address. Once you're done with that, call me back. I tell you what to do with v6. Evading lawful interception seems to be about as challenging as evading antivirus. In 2008, we had the race to zero. Like, how long does it take to, you know, take a well-known virus to evade antivirus engines, every single known one? That was a question of minutes. I'm like tempted to do that for next DEF CON. But the real point here being weakening our critical infrastructure for everyone, just because some lobbyists told some company this is a good idea, and yeah, you will see when this guy downloads the MP3. Disproportionate measure. We don't do that for any other criminal case, even the bigger ones. Why will the internet be different? So basically, to sum up, like how this is built. And if you want to thank the person that like gave this as a sticker to me, go to the info desk when Momo is there. Yeah, I couldn't describe it better. My recommendation, actually, how about we just fucking stop doing that and start fucking. And with that, thanks for giving me the extra time.